Hi, welcome back. It's Professor Rich in today's lesson in section 4.3, Polynomial Divisions, the Remainder Theorem, and the Factor Theorem. Let's review long division with numbers first. So if I asked you to do, say, 685 divided by 21. And so we're going to do 685, that's the dividend, goes inside, divided by 21, goes outside. And the first step we do is we're going to take, we say how many times does 21 go into 68? We're going to do 68 divided by 21. We'll write it this way, 68, this is our first step. 68 divided by 21 is going to be 3 with some remainder. Okay, so then we're going to take that result and write it above the 8. Then we're going to go 3 times 21, which is 63, and we're going to write it below, and we're going to subtract it. So 68 minus 63 is 5. Then we're going to bring down the next number. So it's 5, and then you're going to start over at 1 again and do this loop again. Okay, so you're pretty familiar with long division, hopefully. So 3 times 2 is, 2 times 21 is 42, subtract 13, and then that's a remainder. So we can write remainder 13, or if we want to write it as a fraction, we're going to write 13/21. Alright, so for polynomial division, we're going to follow these same steps with one slight modification. Okay, so the dividing, x cubed plus 5x squared minus 4x minus 3 goes inside, divided by the divisor, x plus 5. And our first step is you're going to do the first term inside, divided by the first term outside. So in this case it's going to be x cubed divided by x, which is x squared. So we're going to take the x squared and write it right above the x cubed. And then we're going to multiply, so I'm going to mimic the steps I did with the numbers. So step 2 is I'm going to take the result from step 1, and multiply by the divisor. So in this case, I'm going to take x squared times the divisor, x plus 5, which equals x cubed plus 5x squared. And we'll write it right below, because I'm going to subtract. And you know what? Let me change this problem. Let's make this an 8. Because I don't want that to be a 0. Okay. So x squared. Now I'm going to subtract, and remember when you subtract you got to distribute the minus sign. So x cubed minus x cubed is 0. 8x squared minus 5x squared is 3x squared. Okay, so subtract. Then we're going to bring down the next term. Instead of the number, you bring down the next term. So we'll bring down the minus 4x. And then we're going to start over at step 1 again. and you keep going until you're left with the remainder. And the way the remainder is the degree of the after you subtract. If the degree of that polynomial is less than the degree of the divisor, then you're done. So here, 3x squared minus 4x, the degree there is 2, which is greater than the divisor. The degree of the divisor is 1, so we got to do the loop again. Okay, so we're going to start at step 1. Okay, so our second loop. Step 1, we're going to do 3x squared divided by x, which is 3x. So we're at plus 3x above. Then we're going to multiply 3x times the x plus 5, which is 3x squared plus 15x. We're going to subtract. So we get 3x squared minus 3x squared is 0. Minus 4x minus 15x is minus 19x. Then you're going to bring down the next term. So let's see. So that's the minus 3. And then we're going to start over at step 1 again. So now we're going to do a third loop. And I'm not going to write it down. I'm going to do the first term, negative 19x. Well, negative 19x divided by x is negative 19. So we write that down. Then you're going to multiply negative 19 times x plus 5. That's negative 19x minus 95. We're going to subtract. So remember, you distribute the minus sign. So it's negative 19 minus a minus 19, which is 0. Negative 3 minus a minus 95, which is positive 92. And that's your remainder. So we're at plus 92 over x plus 5. And that's my solution. Not solution, that's my quotient plus the remainder. Okay, divide. We're going to take x plus 2 into, so it's x to the 4th. Now there's no x cubed, so I'm going to put in the missing term. Or you can just leave it blank and leave space for it. But you want descending order. 0x plus 3. So the x term's missing also. And we're going to divide it by x plus 2. So we're going to start with our first loop. X to the 4th divided by x is going to be x cubed. We multiply. X cubed times x plus 2 is x to the 4th plus 2x cubed. We're going to subtract. So we get minus 2x cubed. Because don't forget, we're distributing the minus sign. Bring down the next term. And we start over. Negative 2x cubed divided by x is negative 2x squared. Now I'm going to just multiply negative 2x squared times x plus 2. That's 2x cubed, negative 2x cubed, minus 4x squared. Now I'm going to subtract. So that will get me positive 2x squared. Bring the next term down. And then start over. 2x squared divided by x is plus 2x. We're going to multiply 2x times x plus 1. We get 2x squared plus 4x. We're going to subtract. So we get minus 4x. Bring the next term down. And start over. Negative 4x divided by x is negative 4. And negative 4 times x plus 2 is negative 4x minus 8. We're going to subtract, so we get 11. There you go. Now note, if you're asked to write, if we have p of x is equal to the x to the fourth minus 2x squared plus 3, and the divisor is equal to the x plus 2, and then you're asked to write p of x as the divisor times the quotient, so q of x is the quotient, plus the remainder. So this is divisor, quotient, and of course that's the remainder. So we can write this like x fourth minus 2x squared plus 3 is equal to the x plus 2 times the quotient, which is the x cubed minus 2x squared plus 2x plus, or minus 4 plus 11. So if you were to multiply the x plus 2 times the quotient, x cubed minus 2x squared plus 2x minus 4, multiply that out, and then add 11 to it, you'll get the original polynomial. Okay? Okay, now let's review synthetic division. Let's divide x cubed minus 4x squared plus 3x minus 2 divided by x plus 3. So if you recall, the way we do this is we're going to put in the opposite of that, right? So we're going to put in negative 3. Okay? And then we're going to put in the coefficients of your x's in descending order. Okay, so we got 1 for x cubed, negative for x squared, 3 for x, and negative 2 for the constant. Now if there's any missing terms, you've got to put 0. You put a line like this, and you're going to bring down the first term, and then you multiply, so no, you multiply always by this number. Multiply. So negative 3 times 1 is negative 3, and then it goes up. Okay, so now we got negative 3. Now you wouldn't rewrite this again, I just, don't want to have all the arrows here. So bring the first term down, negative 3 times 1 is negative 3. And then you add down the columns. So that will be negative 7. And then to move to the next column, you're going to multiply. And then write it up in the next column. So negative 3 times negative 7 is 21. Add down the column, 3 plus 21 is 24. And then you're going to multiply again. And write it up here. So negative 3 times 24 is 72 negative. And then you're going to add down the column and you get negative 74. Okay, now this last line, this is going to be the coefficients of the quotient. And then this, in the last box here, that's the remainder. So x cubed minus 4x squared plus 3x minus 2 divided by x plus 3 is equal to, now this was x cubed, so we divide by x, this is x squared. So it's 1x squared minus 7x, and then you just go descending order, plus constants 24, and then the remainder is negative 74 and then you put that over the divisor. Okay? So there you go. That's synthetic division. Let's do another one. Now to use synthetic division, you can only divide by x plus something or x minus something, right? So you can only use, so here's a note. Okay, so again, we're going to take the opposite, x minus 1, I'm going to take plus 1. I'm going to take, this is degree x to the fourth, so I'm going to start 1x to the fourth, 6x cubed, 0x squared, 0x, and then the constant would be 0. So you got to put in all the missing terms. And then you bring down the first term, 1. We multiply, 1 times 1 is 1. We get 7. 1 times 7 is 7. And we're just going to get a bunch of 7s here. And so this was x to the fourth, so this one's x cubed. So our answer is going to be x cubed plus 7x squared plus 7x plus 7 plus the remainder is 7 over x minus 1. Okay? Now, the remainder theorem, so if a number c is substituted for x in the polynomial f of x, then the result f of c, so whatever value you get by plugging c in and working it out, that result is going to be equal to the remainder, right? So that you would obtain by dividing f of x by f of c. Okay, so we can say that in notation. If f of x equals the divisor's x minus c times the quotient, whatever you get result, plus the remainder is going to be equal to the same value that if you plug c into the polynomial and work it out. So if f of x equals the divisor x minus c times qx plus r, then r, the remainder, is equal to the same thing as plugging c into f and working it out. Okay? So that has some nice results for us. We can figure it with pre-calculator days. It was easier to figure out function values by doing synthetic division. Now we can kind of do it the other way. We can, when you do synthetic division to see if you're going to get a factor, you plug in the number and see if it's a 0. So let me show you what I'm talking about. Okay, so let's use synthetic division to find the function values, then check by substituting into the function, by plugging it into the function. Okay, so we're going to do, now note, if it's written this way, this is, we're dividing by x plus 1, so that's changed from there, but what we put in here for synthetic division, those are the same. Because here, those are opposites. So f of negative 1, this is positive 1, but it's the same thing that I put in here for synthetic division. So we got 1, negative 3, 2, wait, we got x4, x cubed, x squared is 0, x, 8. Bring the first one down, multiply. Negative 1 times 1 is negative 1. Negative 3 plus negative 1 is negative 4. And that negative 1 times negative 4 is positive 4. Add down. Negative 1 times 4 is negative 4. Add down. Negative 1 times negative 2 is 2. Add down. And we get 10. So we're saying, or claim by the remainder theorem is the remainder 10 is equal to the function value if x is negative 1. So let's check it by doing it the other way. F of negative 1 is negative 1 to the 4th minus 3 times negative 1 to the 3rd plus 2 times negative 1 plus 8. So it's 1 plus 3 minus 2 plus 8. So that's 4 minus 2 is 2 plus 8 is 10. Alright, let's try one more. Let's try f of 3. So again, I'm going to do 3, 1, negative 3, 0, 2, 8. One times 3 is 3. That gets me 0. 3 times 0 is 0. 3 times 0 is 0. That's 2. 6. And then 14. So we're saying that f of 3 equals 14. So again, let's check it. If I put in 3 to the 4th minus 3 to the 3rd, 3 plus 8, so we get 81 minus 81, 6 plus 8, which is 14. Okay, so that's a nice little trick. You can actually get function values by doing synthetic division, which is pretty easy. Now the factor theorem, let's talk about that. So if you have a polynomial f of x, if f of c is 0, so again, and we connect it to the remainder theorem, we're saying if the remainder is 0, then x minus c has to be a factor of the polynomial. So we can kind of use this in conjunction with synthetic division. If the remainder is 0, we know that x minus c is a factor. Or we can plug it in, and if it's a 0, the function, if it gets 0, then we know that x minus c is a factor. So you can do it, you can use it either way. Okay, so use synthetic division to determine whether numbers are zeros of the function. So remember, the function value is equal to the remainder. So if I want to find f of negative 4, that's going to be equal to the remainder. So if the remainder is 0, then it's a 0 of the function. And then by the factor theorem, then x minus c, whatever c is, will be a factor of the polynomial. So we're going to get 3, 11, negative 2, 8. So just check descending order. Cubed, squared, x, constant. Good. Bring the first one down. 3 times negative 4 is negative 12. Add down. So that's negative 1. Negative 4 times negative 1 is positive 4. Add down. 4 times, that's negative 8. And that's 0. So yes, negative 4 is a 0. Okay, we've got two parts here. So now we're going to do 2. Same numbers, 3, 11, negative 2, 8. Bring the 3 down. 2 times 3 is 6. That's 17, 34, which is 32. And I can see it's not going to be 0, but we'll finish it. 64, 72. So no, 2 is not. 2 is not a 0. Okay, so that's the two questions. Okay, so factor the polynomial function f of x, and then solve the equation f of x equals 0. So let's look at this one. Say I want to factor f of x equals x cubed minus 6x squared plus 3x plus 10. Has 4 terms, so you try factor by grouping. Doesn't work. Okay. Then now you're stuck. What do? So basically what you're going to do is you're just going to guess numbers, and you're going to look for things that divide into it. So just start out with like 1. So we're just shooting in the dark here. Next section we're going to learn some techniques for, where do we start looking. Okay, but right now all we don't know anything other than we just try numbers, see what divides evenly into this. So we try 1. So 1 times 1 is 1, negative 5, that's negative 2. Okay, so 1's not a factor, so x minus 1 is not a factor. So we're going to try 2. So 1, negative 6, 3, 10. Bring down the 1. Negative 4, negative 8, negative 5, and we got lucky, right? So that is a factor. So x minus 2 is a factor. So we have f of x now is equal to the x minus 2, and it's a factor because the remainder was 0, right? That's the remainder. The remainder is 0, then it's a factor. Okay, and then what's left over, remember this was x cubed, so this is x squared. So 1x squared minus 4x minus 5. And this is a square function that I can just factor normally. Factor 5, subtract the 4. So it's 5 and 1. And then that's negative, positive. Okay, so that's part A. It's factored completely. Now we're going to solve it. X minus 2. We're going to find the zeros for it, So we're going to solve this equation. So we're just going to subtract 2. So x equals, we're going to add 2. We're going to add 5. We're going to subtract 1. So I'm skipping some steps here. So x minus 2 equals 0. So you're going to add 2 to both sides and get x equals 2. And you don't have to show this step. You just change the sign. So you're going to add 5. X plus 1 equals 0. So you're going to subtract 1. So x equals 2, 5, or negative 1. Okay, we'll try another one. And again, we're just kind of blindly checking here. So let's try 3. 1, negative 4, negative 7, 34, negative 24. So we get 1, negative 1, negative 3, negative 30, negative 12, negative 36. So x minus 3 doesn't work. And normally I don't write this. Okay, so let's try 1. Now this is x fourth, so we can factor x squares, so we got to find 2 linear factors so we can get it down to x squared. So let's see, 1. So we're just, again, you're going to learn some techniques to know what numbers to start with. 1. So right now you're just blindly guessing. So that's negative 10. 34 minus 10 is 24. And 24 is 0. So that works. So now we have, this tells us that our f of x is x minus 1 times x cubed minus 3x squared minus 10x plus 24. And so now we need to factor out the x cubed. So let's try 2. 1, and we're going to take this answer 1, negative 3, negative 10, negative 24. That's our third degree polynomial, so we're going to factor that one. So again, we're just blindly guessing. 1 times 2 is 2. 2 times negative 1 is negative 2. Negative 10 plus negative 2 is negative 12. And that's negative 24, and then that one works. So we got lucky. So now f of x is the x plus minus 1 that we already did. And then we found that x minus 2 works in the x cubed thing. And it'll work in the original one too, by the way. And then we're left with x squared minus x minus 12. And then that's a square polynomial, quadratic. We know how to factor those. So what are factors of 12 that subtract to 1? And hopefully you're saying 3 and 4. Bigger one's negative. Signs are different. Now we're going to set this equal to 0. So this is part 1. It's factored. Now we're going to set it equal to 0 and solve. And remember the shortcut, you're just going to change the sign. So x equals 1, positive 2, negative 3, positive 4. And we're done. Okay. So that concludes the lesson for 4.3. Go to My Math Lab and do some exercises there. I'll see you next time.